Hey guys, supernova. What is that and what does that do for you? Um, Basically, a supernova is a star explosion. Now, I gotta clarify that most stars actually don't go under supernovas when they die. They kind of just like fizzle out and die. Only the largest of stars undergo a supernova, and that basically is a huge explosion at the end. So what ends up happening is, as a star grows older, it uses hydrogen as its fuel source, and it fuses hydrogen into helium, a different element. And eventually it runs out of the amount of hydrogen and it starts fusing helium. And basically at the end of the story, it runs out of fuel. And as a result, it starts to expand a little bit. But then it realizes it doesn't have enough energy to sustain this expansion of itself. And so almost suddenly it just loses all the energy that was keeping it expanding, and then all of that just comes in and collapses on itself. So that means you have like thousands of miles of all this gas and plasma just collapsing on itself, in a matter of it just relatively like in a split second, relatively speaking. So what this causes is just like this moment of like great, intense, hot, flaming, just pressure and just collision that then causes a rebound explosion. And that explosion is what you see as a supernova. This is really important in terms of astronomy because it tells us what is happening. Like it serves as like we call it a candle. Basically, that means we know how bright a supernova should be based upon like spectral analysis. That just means analyzing the different elements and the amount of quantities of elements in a supernova explosion. And so we can tell how far away a galaxy is based upon the supernova. So if the supernova is like not that bright, and we see that it has a certain spectral property, we'd say, well, if we were standing right next to the supernova, we would know it would be this amount of brightness. And we see it's not that bright. So based upon the difference in brightness, we can calculate how far that supernova is away from us. And that's really useful because then we know, well, if that supernova is in that galaxy and we know how far away that supernova is, we now know how far that galaxy is. And that just builds our understanding, our coordinates of where everything is in the universe. That's why it's really important. Now, another thing that's kind of interesting after this is that a supernova can create, during that part where it's all imploding on each other and then it explodes outwards, that process itself actually creates what's called a neutron star. This is like the densest thing in the universe. I mean, like a little speck of this, like if I were to try to hold it in my hand, like a little speck would probably weigh more than like a steel freighter, okay, like in the ocean. That's how dense this is. And they actually just came out with a study where they were thinking that this neutron star actually has a different type of matter that composes it. And they call that the pasta model. We don't know if that's true or not, but basically the whole point with this neutron star is that it is so smushed together that the nuclei of atoms, which are normally like, relatively speaking, very far apart, are actually situated right next to each other. It's like a soup of nuclei atoms. So with that being said, it has very different properties, and we can get into that later, but the whole point with the supernova, at least, is it's a good candle because it allows us to see where it is in the universe and how big it is, and it also helps us explain how neutron stars got there in the first place. Now, there's another result of a supernova, which you guys are probably more familiar with, and that's a black hole. So supernovas, if they're big enough, can actually result in a black hole during that like collision, that implosion part. A lot of them go to neutron stars, but every once in a while you get a black hole, and we'll do a separate video on that. But that's kind of the origin of black holes, and it's kind of interesting how they got there. We really use supernovas as explanations for other things that exist in the universe. So, all right, guys, thanks.